3. The binomial distribution. Consider an experiment with two possible outcomes, one of which may be termed as success and the other failure. This is known as Bernoulli trial. When this experiment is repeated a number of times, it gives rise to a binomial distribution. For example, toss a coin 6 times, consider obtaining a head on a single toss as a success and obtaining a tail as a failure. Throw a die 10 times, considering obtaining a score of 6 on a single throw as a success and not obtaining a 6 as a failure. Conditions for a binomial distribution. 1. The experiment consists of n independent repeated trials. 2. Each trial has two possible outcomes, either a success or a failure. 3. The probability of a success is the same in each trial. If the above conditions are satisfied, then the random variable x, representing the number of successes in the n trials, is called a binomial random variable. Definition. If the binomial trial results in a success with probability p, then we have the probability of success is p and the probability of failure is q, where q is equals to 1 minus p. Then we have the probability distribution of x is given by probability of x equals to x is equals to nc x p to the power x 1 minus p to the power n minus x, where x takes the value from 0 right up to n, and the probability of p is between 0 and 1. This random variable x has a binomial distribution with parameters n and p that is represented symbolically as x follows a binomial b, n number of trials, and p is the probability of a success. Example 2. A box contains a large number of balls in a proportion of 1 white ball to 4 black balls. 120 balls are randomly drawn one by one and without replacement from the box. The random variable x is the number of black balls drawn. State a suitable model for distribution of x and justify your answer. The binomial model is suitable because 1. There is a fixed number of independent trials, where n is 120. 2. Each trial has two possible outcomes, either a success, drawing a black ball, or a failure, drawing a white ball. 3. Since the box contains a large number of balls, where n is more than 30, the probability of drawing a black ball is approximately a constant, although the balls are drawn without replacement. Note, the last point is an assumption made to ensure that we conform to the condition for a binomial model, which requires that the probability of success is the same in each trial. Let's look at example 3 to illustrate how do we work out binomial problems. Find the probability of getting 5 heads in 12 flips of a balanced coin. Note the characteristics of the binomial distribution here. 1. The experiment consists of 12 independent trials. There is a fixed number of trials. 2. Each trial has two possible outcomes, either getting a head, which is a success, or a tail, a failure. And 3. The probability of getting a head, a success, is the same in each flip. When solving binomial problems, you need to take note of the following. 1. Define the random variable. Let x be the random variable, the number of heads obtained in 12 flips. 2. State the distribution of the random variable. Taking note of the value of n and the value of p. Therefore, x follows a binomial 12, half. 3. Write down the required probability as stated in the question. Probability of x is equals to 5, and using a GC you have a value 0.1934. The command for GC is as shown. Second variable, A, selecting binom PDF. Taking note that when it's equal, it is PDF. Key in the parameters for binom PDF with the n value, p value, and x value to compute probability of x equals to 5 as shown in the screenshot. Example 4. An automobile safety engineer claims that 1 in 10 automobile accidents is due to driver fatigue. What is the probability that at most 2 of 5 automobile accidents are due to driver fatigue? 1. Define the random variable. Let x be the random variable, the number of accidents due to driver fatigue. 2. State the distribution of the random variable. Taking note that n is 5, the probability is 0.1. Therefore, x follows a binomial 5, 0.1. 3. Write down the required probability. Probability of x is less than or equals to 2, and using your GC you end up with a value of 0.9914, and to 3 significant figures 0.991. The GC command is as shown. Taking note as well, if inequalities is involved, it will be binom CDF.